Assalamu alaikum wa rahmatullahi wa barakatuh. Hi guys, how are you? This is science lessons for grade 3. And today inshallah we're gonna talk about chapter 2. Okay, and this is lesson 6, session 2. What is electrical energy? This is session 2. What is electrical energy? You're gonna find this in the booklet page 76. As you remember, last session we talked about electrical energy and electric circuit. And today we're gonna talk more about electrical circuit, okay? So let's watch this video to know more about electrical energy.
All matter is made up of small particles that have an electric charge. An electric charge is a tiny amount of energy. The movement of an electric charge from one place to another is called electric current. When this current travels through a controlled path, like wires, it can provide energy to turn on a light or make a TV work.
Okay guys, I have a question for you here. What's moving inside the electric wires, okay? Or it's a tiny energy, okay? We call it electric charge. Electric charge. Excellent. So this electric charge flows through the wires. When the electric charges flow through the wires, we call this flowing, okay, electric current. Excellent. Electric current. Okay, let's continue to this part here. Yes, the electric current moves through those wires to make the lights, yes, on at home, okay, or the TV work. So what make this TV work? Can you tell me? Electric current. Excellent. Okay, let's continue.
The path a controlled electric current flows through is called a circuit. A circuit must be unbroken with no gaps, or a closed circuit, for electric current to flow through it. When a circuit has a broken path, it's called an open circuit. A switch can provide an easy change between closed and open circuits.
Okay guys, let's back to this part here. We talk about electric circuit. Electric circuit. Okay, what's the meaning of electric circuit? Electric circuit, we have, okay, here, number 1, electric source, it's the battery. Here we have battery, it's electrical source. And we have number 2, wires, okay, for the charges to move in it. And we have here, something needs energy to work, or electricity to work, okay. Maybe something like this, object like this, needs the electricity to move, or maybe light bulb. Okay, so this is electric circuit. Excellent. And what is this, teacher? It's a switch to open and close. Open and close. Okay, so this is closed circuit. What's the meaning of this? No gaps in it, okay. Not the switch is on and the circuit is closed. There is no gaps or brokens in it, okay. The whole wires is connect together, nothing wrong, nothing breaks the circuit. But here, oh, this wire don't connect it to this object, okay. So this is, can you tell me? Yes, open circuit. Why? Because there is a gap, open area here in the wires. This wire don't connect here, so this circuit is broken or open circuit. Okay, let's continue.
A switch can provide an easy change between closed and open circuits. When the switch is down, the circuit has no gaps and the light turns on. But when the switch is up, it creates a hole in the circuit. This stops electricity from flowing to the light.
Okay guys, what's the material this switch made of? Copper maybe, or metal, okay. So when I switch this here, yes, when I switch it on, So the circuit is closed. You see the light bulb here, lights, yes, and everything is okay. Why? Because I close it. There is no break in the circuit, no gap. But when I open it, oh, there is a gap in the circuit here. The charges can't move from this side to this side. No, can't move from this side to this side. And remember, guys, charges move from the negative. Yes, it's the minus here, negative part or negative side to the positive, from the negative to the positive. So the charges can't move. Why? Because there is a hole or a gap in the circuit. So this is closed or open circuit. Open circuit.
It creates a hole in the circuit. This stops electricity from flowing to the light. Every circuit needs an energy source. The outlets in your home get electricity from a power plant. Batteries can also provide electrical energy for a CD player or a flashlight. Got it? Sure you do.
Okay guys, so let's back to the book, page 76. And if the switch is off, this is open circuit. Electric circuit is broken or open. If the switch is on, the circuit is closed. The charges can move and the path must be unbroken. Unbroken, there is no holes or cuts or gaps in the wires. Okay, battery here, as you see, battery is the source of energy. Circuit, this electric circuit is made from number 1, battery, number 2, wires, and number 3, light bulb. Okay, 3 things or 3 components. Number 1, battery, it's the electric source. Number 2, wires. Number 3, light bulb. Okay, so let's see here each component of the electric circuit. Number 1 here, wire, yes. The current flow through the wire toward the opposite part of the battery, like here. The current moves through the wires to the opposite part of the battery. It moves from this negative part, move through the wires to the positive part. Okay, a switch, this is the switch, allows you to open and close a circuit without disconnecting a wire and light the bulb. So I can open the switch, close the switch. Okay, I don't need to take off the wires and put the wires again and take off the wires every time. No, I just open and close the switch. Okay, battery. Battery is the energy source. Electric current flows from the negative, remember guys, negative part of the battery to the positive part. Light bulb current passes through the bulb, which contains a small wire lobe. What is wire lobe, teacher? Let me show you. Here, can you see inside the light bulb? Yeah, this is the wire lobe, which get hot or heat and give me light. This is the wire lobe. Okay, here, let's see. Wire lobe. The wire lobe heat and glow, giving me light. Okay guys, I hope you got it. Let's now move to the next slide, and as you see, we have this nice video. It talks about electric circuit. Okay, we have here a closed electric circuit, and the lights here is, yes, light. Okay, giving me light. It's on. Let's watch this video together. No, back to the video. Let's watch it together.
Hello? What's going on, young scientist? Hi, I'm trying to make an electric circuit. Electric circuit? Wow! Have you learned that in school? Yeah, a move in a wire, we say that an electric current flows in the wire. It's like the way a current of water flows in a river.
Yeah, it is like a constant flow of electrons through something.
When a wire is connected to each end of the battery, electrons begin to flow from negative to positive.
Yeah, from minus to plus.
And this flow of electrons is called current. Now look at this.
Hey, there is no battery in this.
Yeah, if there is no battery, no electricity will flow.
So guys, if there is no battery in the circuit, it will be electric circuit? No. Why? Because I don't have the electric source. I don't have the battery, so no electricity, no energy. Okay, let's continue.
So, the first condition for the flow of electricity in a circuit is that there should be something to make the electrons flow. Now look at this second circuit. What is missing? Oh,
Okay guys, can you tell me this circuit here, it's open or closed? Let's see, it have some open area in the wires? Yes, it have open area here, so it's open circuit. Why? Because the wires don't get or don't connect to the light bulb. So we have here open area. So this is open circuit. Excellent. No charges can move to the light bulb. Good job.
second circuit. What is missing?
Oh, the circuit is not complete.
Correct. This is an incomplete circuit. You need a complete path for the current to flow in. This is called an electric circuit.
So you need some power source like a cell or a battery, and you need full circuit for electric charge to flow.
Yeah, here it is.
Okay, so guys, can you tell me this is open or closed circuit? Let's see. Is there any open area in the wires? No. So this is open? No. Closed circuit. And if we look at the light bulb, it's light. Yes, the light is on. So this means this is closed circuit. This means the electric current moves through the wires and make the light bulb works. Okay, let's continue.
Look at my circuit. It has a battery and two bulbs, and it is complete with wires.
Yeah, it is very good. This kind of circuit is known as simple or series circuit.
Oh, so if this is
Okay
a
guys, so let's move to page 77. Open circuit and closed circuit. Okay. What's the meaning of open circuit? A circuit with a broken path. A broken path, like this switch is off. So we have here open area. Okay. So current will not flow through an open circuit. The light bulb is off here. Okay, let's look at the closed circuit. A circuit with no gaps or breaks. Let's look. There is no gaps or breaks. And guys, here this is not gaps. Okay, just they missed the line, but this is not gaps. Electric current will continue to flow through a closed circuit until it's broken. Okay, so let me draw, yes, the lines with you like this. It's a closed circuit, not opened. Closed circuit. Okay, guys, you got it? I hope so. Okay, let's erase this. Okay, the light bulb is on. That means that the current or the charges move in the wires. Okay, so now let's talk about conductors and insulators. If you remember, we already talked about conductors and insulators last session, but let's talk about them again. Okay. Okay guys, so let's watch this video to know more about conductor and insulator.
Material that allows the flow of negatively charged electrons in one or more direction, which results in electric current. An electrical insulator is a material in which the electrons do not flow freely. What we will do in
Okay guys, so here conductor lit the currents, electric current or electric charge move through it. So green for go, move through it easily. But insulator, no, stop the electric charges, don't move through it. Okay, so let's
this
continue.
video is take a look at some different objects. We have some metals, some plastics, a Sharpie. How about a pickle and some water? We will hook it up to some electricity and see if it is a conductor or an insulator. Up first, we have copper. Hook it up, and yes, it's a conductor. How about this piece?
Okay guys, so this is copper. Again, copper. When we turn on the switch, the light bulb, yes, works. So this means copper is a conductor. It let the electric charges move through it. Okay, so let's try again. Yes, copper. Okay.
Hook it up, and yes.
Yeah, so copper is a
How
conductor.
about this piece of plastic?
So this is
With the
plastic.
switch, nothing happens. It is going to be an
Nothing
insulator.
happens. So this is
Now we move on
insulator.
to another piece of metal. It's aluminum. Flip the switch.
So this is aluminium. Okay, so let's see what will happen with aluminium. Okay, let's try.
It is a conductor.
Wow, it is a conductor. Can you see this? Aluminium is a conductor, so you see the light bulb is working.
Now how about some wood? Hook it up. Flip the switch. Nothing happens. So it
Nothing
is an
happens, so this means that what is insulator? Okay.
After the block of wood, let's try this. How about we try a Sharpie? It's plastic, it's hooked up, we go to the switch, and nothing happens. So it is an insulator.
So this plastic here
How about
insulator.
this? Let's try some water. I've got two nails hooked in, I flip the switch, nothing happens. Well, let's modify the water slightly. Let's add some salt. As I add the salt, I pour it in, I go back to the switch. What do you think? Is it going to change? I hit the switch, and yes, it is now a conductor. The salt allows the electrons to move freely. Next, let's try this screwdriver. The reason why I use this, I have plastic on one end.
Okay guys, so if we back here to this part, okay, pure water is insulator. Pure water is insulator, but salt water is a conductor. Again, salt water is a conductor. When the water have salt, so it's a conductor. But pure water, no, insulator.
Conductor. The salt allows the electrons to move freely. Next, let's try this screwdriver. The reason why I use this, I have plastic on one end, nut on the other. I flip the switch, nothing happens. But now, if I move it to where it is touching metal only, it's now a conductor. So the plastic helps insulate it. How about this? How about the pickle? It has a lot of salt in it. Well, I don't know about that. I plug it in. It smokes a lot. It glows. But I would consider it an insulator. How about celery? It kind of tastes salty. Maybe it has enough salt in there. I plug it in, and, well, you can see for yourself. Nothing really happens. Well, it does start smoking a little bit. So let's see what happens with the celery with 110 volts coming through it.
Okay guys, so it's insulator too. Okay, so let's back to the PowerPoint. Okay guys, let's continue, and remember with me that pure water is Not a conductor, it's just a very weak conductor. Pure water is a very weak conductor, but when we look like insulators, okay, very weak conductor, but when we add salt, it's a conductor. Good job. Okay guys, so let's back to conductors and insulators and the definition. What's the meaning of conductors? They are materials which let electric charges move through it easily. Insulators, they are materials that stop the movement of electric charges. Examples for conductors: metal like copper, gold, silver, aluminium, graphite, and water. Insulator like rubber, plastic, glass, and wood. They are materials stop the electric charges. Okay guys, so we want to classify conductors. We make the experiment like we watch in the video. You can use a circuit to investigate whether an object is a conductor or insulator. I hope you like the video. Electricity can change the different forms of energy. Like electricity change from electricity to become a light energy, and can change electricity to heat in this heater. Okay, can change to sound in this maybe CD player, and electricity change to magnetic force. Like we have electric magnet, and this electric magnet we use it to build huge buildings. Okay, so electric magnet like this help me to lift, or help engineers and workers to lift heavy parts of metal high. Okay, so I hope you got it. Now we're gonna answer some questions together. Write the word next to the description it matches. Number 1, a circuit with no gaps or breaks. It have no opens, so it's a closed circuit. Good job. Number 2, a circuit with an open path. Open, so it's open circuit. Good job. Okay, answer the questions on the lines below. Number 1, what happens if two objects with opposite charges are near each other? This means they will attract, because one is positive and the other one is negative. Number 2, what is the difference between conductors and insulators? Can you tell me? Yeah, conductors are materials which let the electric charges move through it easily, move or pass through it easily. Okay, insulators, yes, it's materials that stop the movement of electric charges. Okay, here conductors, can you give me examples? Metals like iron, steel, copper, gold, silver, graphite, okay, and salt water. Okay, insulators like wood, plastic, rubber, glass. Okay, so true or false? Lightning is a kind of electric current, electric circuit. It's not electric current, electric circuit. True or false? Lightning is a kind of electric circuit. True. Okay, number 2, an open switch breaks an electric circuit. Open switch breaks an electric circuit. Yes, true. Excellent. Number 3, pure water conduct electricity. Yes, true, but it's a weak conductor. Number 4, electric current flows from positive part of the battery. No, false, from negative part. Number 5, copper and iron conduct electricity. Yes, true. Number 6, matter with more negative charges than positive. Okay, it has more negative, so we call it overall negative charge. Yes, true. Good job. Okay guys, so let's move to the new words. Materials through which electric charges move easily. Like this metal here, they are conductors. Good job. Okay, this piece of wood here. Let electric charges move? No. Copper, yes. Glass, no. Okay, steel, yes. So, materials that stop the movement of electric charge, like wood and glass, they are insulators. Good job, insulators. And guys, this is all for today. See you next time, inshallah. Bye.